Good morning, everybody. I would like to talk with you about jmarinas, a software that I developed during my master thesis for the production of distribution of portuality risk in small harbors. What we mean with portuality risk is, in general, a definition of how a region in the harbor could be subject to pollution. That measure could be helpful for researchers and managers in the definition of samplings campaigns or in general management of the harbor. To explain you how jmarinas works, I will show you some screenshot, a short movie from the software itself, and I would like to remember you that you can download it for free from the website jmarinas.sf.net. jmarinas works on 4 different variables for the definition of the portuality risk: the pollutant sources distance, the harbor's mouth distance, the tortuosity, and the bathymetry. Each of these variables is weighted with a weight that is defined in the validation process. I want to show you how the input the user can relate with the software for the definition of the different variables. The very first thing that we have to do in jmarinas is to select and import the map over which we want to work. The next step is to draw over that map a polygon that defines the surface of the harbor over which we will work in the next steps of the model. We can also define the prevalent wind, drawing an arrow defining the direction and giving a value of the intensity of that wind. In the next step, we can define what are the pollutant sources in the harbor. We firstly decide what is the kind of the pollutant, and then we decide what is the relative intensity of the pollutant in the harbor. We can divide in the model the pollutants in 3 kinds: one the dystrophic, the chemical, and the hygienical sanitary pollutant risk. In that way, what we will obtain are 3 different metrics, one for each kind of pollutant, and a matrix that consider all of the pollutant in the harbor. In the next step, we define what is the position of the harbor's mouth and what are the general the pollutants that cross the harbor. We cannot decide in the specific what is the pollutant, but we can decide what is the category of pollutant and what is the intensity of that pollution. At the end, what will be obtained are 5 matrices: 4 for the pollutants and 1 for the distance to a side from the harbor's mouth, and that is considered an advantage for a site. In the next step, we are going to consider the value of the variable of tortuosity. What you have to do is to design in the harbor's phase what are all of the structures that can influence the value of tortuosity. Of course, the boundary are important, but also the presence of piers and what kind of piers it is. After the tortuosity, we go to consider the value of the bathymetry. We draw on the map the several points and we assign to each point the value of depth, and we let the tool consider and calculate the value of the other points of the harbor. In general, we consider an advantage for the harbor, for the circulation in the harbor, to be in a depth instead of in a shallow water. Once we have calculated all of the different variables, we can evaluate what is the value of the portuality risk. We divide this information in 4 different matrices, one for each kind of pollution: dystrophic, chemical, and hygienic sanitary, and the last one for the total portuality risk. The tool allows also the evaluation of another variable that we consider of extreme importance in the definition of the harbor risk of pollution. That is the vulnerability. Vulnerability is a kind of collection of several different characteristics of the harbor, like for example the surface, the perimeter, and the circularity. That variable is considered interesting for the comparison of 2 different harbors with different characteristics. Further development of jmarinas will go in the direction of more usability and the definition of the weights of the different variables. I would like to say thank you to everybody that helped me in the realization of jmarinas, and especially the University of Genova and DeepTress. I would like to say thank you to Alain Vatican that gave me the first prize and allowed me to continue my study in this project.